Completing this square. In this video, I'm going to show you how to solve a quadratic equation, or how to find the solutions to a quadratic equations by completing the square. Now, this method is used for quadratics, and it is a very interesting method. How it works? Well, you have to follow certain steps. You have to be careful with what you move, and understand what is A, what is B, and what is C from a quadratic equation. Now remember, a quadratic equation, when it's written in standard form, it looks like this: ax squared plus b x plus c, and it's equal to 0. So the first thing that we're going to do is, if you notice in this step, c is on the right hand side of the equal sign. It is moved away from these two terms, the x squared term and the x term. So they moved it away. So they moved c away from those two. After you do that, after you make sure that it's moved away, then we have these squares. Something is going to go in these blanks here. What goes there is this number. We're going to take a number, which is b to be exact. We're going to divide it by 2, and then the answer that we get from dividing by 2, we're going to double it. We're going to square it. So that's going to go on both sides of the equal sign. Because what you do to one side, you're going to have to do it to the other. So the next step would be to factor. So we would factor the left hand side, and we actually get something that looks like this: x plus the number you got when you divided it by 2. There's going to be two binomials that look like that, two of these. So the shorter way of writing it is this here. There's two of them that are exactly the same. Now, because this is equal to 0, we need to solve for x. How do you solve for x? You need to isolate it, get it by itself. So, to get rid of this power of 2, you need to take the square root. What you do to one side, then you gotta do it to the other side. Then of course, after you take the square root, don't forget there is a plus or minus sign, and then you solve for x. So we're going to follow these steps in this example that we have here, because I know they're kind of confusing to understand. Okay, so the very first step is, how can we make our equation look like this? Well, start off by moving c. This is A, this is B, this is C. We got to move c to the other side of the equal sign. So I'm going to move c over to the right hand side. So I need the additive inverse. Okay, I'm going to rewrite my equation, but I'm going to leave a blank here, and this is equal to 7, and another blank here. Something goes in those blanks. According to this formula, we're going to take the value of b, so this is A, this is B. We're going to take 8, so I'm going to write it down. B is 8. We're going to divide it by 2. So 8 divided by 2 gives us 4. And then we're going to square it. So 4 squared gives us 16. Now that is a positive 16, so I'm going to add 16 here. Now what I do to one side, I gotta do it to the other. Add 16 on that side. So I'm going to go ahead and erase this because I need the space. Again, what I did is I took the value of b, which is 8. I divided that number by 2. The answer I got, I squared it. Okay, so what I'm going to do next is I'm going to factor. Now remember, factoring, there's no number here, so I'm going to take the factors of 16 do my x, 16 goes here, 8 goes here. What two numbers are they? Well, 4 and 4, and they're both positive. Okay, so there's a shortcut of doing this. Instead of doing the x, automatically we're going to do this setup. Okay, x goes here. Now the number that goes in here is an answer that we got when we divided the b value by 2. So when we divided 8 by 2, we had a positive 4. So a plus 4 goes there. And there you go, it's factored. There's 2 of these binomials, but instead of writing both of them out, I'm writing it as the short way. Okay, so on the right hand side, we just got to combine 7 and 16, which give us 23. Okay, so we're going to solve for x, which is what we've always done, but x is in here. There's a little power of 2 in the way, so I need to get rid of that power of 2 first, because it's keeping me from entering the parentheses, what's inside. So to get rid of this power of 2, I need to do the inverse, which is take the square root. So what I do to one side, I got to do it to the other. Power of 2 cancels out with the square root. So now I have x plus 4 is equal to, now remember, when you take the square root of something, you cannot forget the plus or minus symbol. So plus or minus the square root of 23. So I'm almost done getting x by itself. I just got to move the 4. Now I'm going to move the 4 and I'm going to squeeze it right there in front of all of this. When I move the 4 over, it becomes a minus 4. Cross that out. So I'm going to rewrite my equation, or my answer. X is equal to negative 4 plus or minus square root of 23. Your last step will be okay. Remember, there's two answers for this. There's negative 4 plus square root of 23. And then there's the negative 4 minus square root of 23. Okay, so type that into the calculator, round to the nearest tenth, and that will be your answer. So for now, I'm going to leave my answers like this. Okay, so let's try another one, because again, I know this can be confusing. We've already seen 3-4 different methods. Plus this one, yes, I understand how things can get a little crazy. Okay. So, I'm going to draw a picture of what's happening here. Okay, so I'm going to describe this part using algebra tiles. Yes, I know you don't like them. So, here is the x squared. It is a big X. Then it says that I need 4 long rectangles. Now, I'm going to use them to where I get an even amount on both sides of my setup. So there it is. 4 long ones to be equal. I decided to put 2 on this side, 2 on that one. Okay, now the whole purpose of completing the square is, if you notice here, I have a huge gap. In the end, my goal is I'm trying to get a huge square built by these tiles. Now, if I'm trying to build a huge square, then I need to figure out what am I going to fill in here. Okay, so what we could use to fill in, well, we have 3 options: big squares, rectangles, or little squares. The only thing that we have remaining will be little squares. I know they don't look all even, but they should be. Okay, so those are my little squares. Maybe let me make them a little better. Okay, now I know you don't like algebra tiles, but completing the square is okay. What are the dimensions that took us to make a perfect square shape, perfect square, out of all these tiles put together? And remember, we only started off with the big one, the x squared, and 4 long rectangles because that's why we had a 4x. Okay, so what we need up here is a long rectangle, and that is represented by an x, and we needed 2 little ones, 2 little squares, which is 1 and 1. So up here we have x plus 2. On this side, on the left hand side, I needed a long rectangle and I needed 2 little squares. Well, doesn't this look like this? So on this side we have x plus 2 as well. X plus 2. So the dimensions are x plus 2 and x plus 2. What's another way of writing x plus 2 times x plus 2? We have 2 of them. Okay, so now let's go ahead and solve using the steps, and you're gonna understand, or hopefully you see how we get this part. Okay, so completing the square, the first thing you want to do is you want to move the c value away from these two terms. If it's not away, move it. So I'm going to move it by adding. Okay. Next I'm going to rewrite it. X squared plus 4x. I moved the 5, so I have a space. 0 plus 5 on the right hand side give us a 5. On this blank, what we put in there, remember, is first identify the value of b. b is 4. So if we divide 4 by 2, we get a 2. If we square it, we end up with a 4. It just so happens to be that way. So we end up with a 4 again. And it is positive, so I'm going to add a 4 here, and I'm going to add a 4 here. Okay, I'm going to erase this. Then we factor. X goes here. Now, what you put in here, let's not forget the squared, is the answer that we got when we divided this by 2. So 4 divided by 2 is a positive 2. So a positive 2 goes there. On the right hand side, 5 plus 4 is 9, so we have a 9. Now if you notice, this is the same thing as this. It's the dimensions. It's what we needed to build to give us this perfect square. Okay. If you notice, we needed 4 little tiles to complete the square. That's why we had to put a plus 4 on both sides of the equal sign. Okay. So now it's time to get this x completely isolated, which means get rid of this power of 2 first. So to get rid of the power of 2 I should say, my mistake, I need to take the square root. So what I do to one side, I gotta do it to the other. Power of 2 cancels out with the square root of 2. So now I have x plus 2 is equal to, don't forget, plus or minus. Now square root of 9. 9 is a perfect square. It is 3 and 3. Okay, so the square root of 9 is just 3. No more square root symbol. Okay, we don't need it. Alright, the next step will be, we're trying to get x by itself, so move the 2. How do you move it? Do the inverse. So I'm going to squeeze it in right there, and I'm going to subtract it, because it is the inverse of adding. So now I have that x is negative 2 plus or minus 3. And remember, we have two options. X could be negative 2 plus 3, which give us 1, or x could be negative 2 minus 3, which in this case give us a negative 5. So our two solutions will be x is equal to 1. Let me write it up here, I'm out of space. Our two solutions are x is equal to negative 5, the smallest number comes first, comma 1. And we use curly braces. Okay, So let's try another one. Now, the difference between this one and the two problems that I've worked out is that this has a leading coefficient that is not 1. It is a 3. For the purposes of completing the square, what we need to do is get rid of that 3. How do you get rid of the 3? Divide everything by 3. Every single little thing gets divided by 3. So now, my new equation looks like this. X squared minus 3x minus 1 is equal to 7. Okay, so now we can start completing the square. If you want, I'm going to go ahead and, well, not if you want, I'm going to go ahead and show you how to find the end, or how to understand completing the square by using pictures. Okay, so this big square comes from the x squared. Then I need 3 long ones, but as you can tell, if I need 3 long ones, then I need an even amount. So how can I have an even amount and end up with a square? I can't do that. Or even if I switch it this way, there's no way of keeping it even. So we're going to end up with fractions, unfortunately. The first thing we got to do is move C away from these two terms. Okay, so we're going to add it to this number that's already on the right hand side. We're going to add the 1, and we're going to rewrite this. X squared minus 3x, there's a blank, is equal to 8. What goes in that blank? Well, we're going to take the value of b, which is negative 3, and we're going to divide it by 2, which it doesn't reduce, it stays as negative 3 over 2. Next, we're going to square that answer. This becomes 9 over 4. So what that means is, since it's a positive 9 over 4, we are going to add 9 over 4 on both sides of the equal sign. 9 over 4. My next step is to factor, but I don't really have to factor because I've already done that. X, don't forget it's squared. What answer did we get when we divided negative 3 by 2? Negative 3 over 2. So minus 3 over 2 goes in there. Alright, the right hand side, 8 plus 9 over 4. And we get 41 over 4. Keep it as a fraction. Don't change anything to a decimal yet. Alright, so we're trying to get x isolated. What we're going to do is, how do you get rid of this power of 2? You take the square root. What you do to one side, you gotta do it to the other side. So the square root cancels out with the power of 2. Now because I'm running out of space, I'm gonna rewrite after I took the square root. Then I have this. Plus or minus the square root of 41 divided by 4. 41 is not a perfect square, so I'm going to keep it like that. Square root of 41 over 4. Now, the next thing I'm going to do is, I'm trying to get x by itself, so I'm going to move this fraction over and I'm going to squeeze it in right there. How do you move negative 3 over 2? Well, we're going to add 3 over 2. Okay, so then we end up with this here. X is equal to a positive 3 over 2 plus or minus the square root of 41 over 4. It looks kind of ugly, but good thing we have a nice calculator. 3 over 2 plus the square root of 41 over 4. Type that into the calculator. And we're going to estimate, we're going to round the answer to the nearest tenth. And on this side, we get 3 over 2 minus the square root of 41 over 4. Type that into the calculator, estimate the answer, round to the nearest tenth, and those will be our two solutions, whatever we get after you type it in the calculator. So, I hope this method helps you understand how to solve quadratics using the completing the square method.